welcome back. In this video, we are going to look at evaluating trigonometric functions, and also we will be looking at right triangle-based definition of trigonometric functions. We will also be looking at trig function values of special angles and reference angle. We will be looking at all that, and that's all what we're going to do under this video. So let's start with evaluating trigonometric functions, and we go like that. Alright, so we all know this already. We all know this already. Alright, we have already established that the side of length y is called the side of opposite angle A. The side of length S is called the side adjacent angle, and the alright, and the R also represents the hypotenuse and all that. So let's look at right triangle-based definition of trigonometric functions. Right triangle-based definition of trigonometric functions. So we have already established that. We know that sine is opposite over the hypotenuse. You can be writing in case you still need it. Cos is adjacent over hypotenuse, and tan is opposite over adjacent. We also know that cosec is a reciprocal of sine, and that is hypotenuse over the opposite. And we also know that sec is a reciprocal for cos, and that is hypotenuse over the adjacent. And cot is a reciprocal of tan, and that is adjacent over the opposite. Alright, so let's look at the trigonometric function value of special angle. The trigonometric function value of special angle. Alright, so looking at the trigonometric value of special angle, we are going to base our concept or idea on equilateral triangle. So we know that for every equilateral triangle, all the sides are equal. So that means that if here is 2, here is 2, here is 2. Alright, and also the angles are also the same. The angles are also the same. And we know that interior angle of a triangle sum up to 360. So when you divide 360 by 3, you are going to get 60, 60, 60. So that is what we have for equilateral triangle. So when you bisect this equilateral triangle, we are going to bisect this equilateral triangle, and we are going to get 1 to be this. Alright, here is going to be 60, alright, 90 will form here. Then here is going to be 30. Alright, very good. And the other one will be also like this. Here is going to be 60, alright, but here will be 30. That is it. Here will be 2. Here, since we have bisected it, from here to here is what? Is the 2. So here will be 1 and here will be 1. Very good. But this is the case that we don't know this side. Let's represent that by A. So when we represent the opposite side by A, then we go and find that. Knowing that whatever you get here is the same as whatever you get here. So from Pythagorean identity, we can go for, here is 2. We can go for 8. Knowing that A 1 square plus A square is equal to 2 square. So A square is equal to 2 square minus what? 1 square. So a is equal to the square root of what? 3. So we get this to be equal to the square root of 3. Here the same thing. A is equal to the square root of what? 3. So that is what we are going to have for that. Alright, so now here we have 2 angles here, alright. We have the one that is making with 60 degrees and the one that is making with 30 degrees. You know that this triangle, this right angle triangle, please watch well. This right angle triangle, we can first of all, we can let it be like this. Here is 30 degrees. Here we know. Here is 60 degrees. Here we know. We know now that here is square root of 3. Here is 2. Here is 1. Here, the angle here is 60 degrees. So our base, or let me say, our idea is that here, whenever you come out with anything from this right angle triangle, it's going to be based on the angle 60. And with this, we can also redraw. We can let it be like this, alright, so that we get something like this. Something like this. We can also turn it this way. We can let the 60 degrees come here, then the 30 degrees will be here, and then that. So here, the 1 will be here, then the square root of 3 will now be here, and here will still be what? 2. Alright. Now, you have to also take note that the angle that we will get from this 60 degrees is different from the one that we get for what? The 30 degrees. So let's look at the one that we will get for 30 degrees. Sorry, for the 60 degrees. So first, when you are looking for sine 60, sine 60 is going to be opposite over what? The hypotenuse. So the opposite is square root of 3. The hypotenuse is what? 2. When you come to cos 60, cos 60, you are going to get adjacent over the hypotenuse. So that is going to be 1 over the adjacent. Alright? So that is the adjacent over the hypotenuse, S over R. So that is going to be 1 over what? The 2. 1 over the 2. That will be cos. So when we come to tan 60 is y over s. So the y square root of 3 over s, which is 1. So here we just get that. 4 is the reciprocal identity, which is what? Let's go for cosec. Cosec 60. Cosec 60 is going to give you the reciprocal of this. So we get 2 over square root of 3. And the 5 is sec. Sec 60 will also give you the reciprocal for cos. So here you get 2 over 1. And the last one, cot. Cot 60 will be giving you the reciprocal for tan. And that is square root of 3. Alright, sorry, that was 1 over square root of 3. So that is what we are going to have for that. Now let's go for the reference angle 60 degrees. When we use 60 degrees as our, listen, I haven't come to reference angle. From here we are going to reference angle, so I don't want to use the word reference, alright? Okay, so when we base our angle on 30 degrees, we are going to get here to be, I would like you to do this one for me, okay? Try on this and do this one for me. So when we base on the 30 degrees, what are we going to get for sine 60? Sorry, sine 30 degrees, tan 30 degrees, cos 30 degrees, and the likes. Continue for me. Know that sine 30 will be 1 over 2. because it's going to be the opposite over the hypotenuse. Alright, so continue for me on that part. Good. So from here, we can also get a 45 degrees to be our reference angle. We can, to be the one that we are basing on. So it's not always 30 and 60. We can also get 45. How, in what way are we going to get that to be 45? Alright. So let's see. For 45 degrees, for 45 degrees, we know that interior angle sum up to what? 180. So for 45 degrees, if here is 90, then if here is 45, here too can be 45. And 45 plus 45 plus 90 will give you 180. Alright, so that is that for this side. So what are we going to do now? Okay, so with that, we are going to set here to the square root of 2, 1, 1. Then let's go for sine 45, 2 cos 45. I would like you to be doing that. Tan 45 and the likes. Continue with it. So here we get opposite over the hypotenuse. So 1 over square root of 2 and the likes. Continue. Okay, here we get for tan, that is 1 over, for cos, that will be 1 over the hypotenuse. So 1 over square root of 2. Alright, so continue with the rest. Okay, so let's move on to definition. Let's move on to reference angle. We are moving on to reference angle. So I would like you to complete